Hi students, we are going to learn about the part 3 of the functions. Image of an interval. To find the image of an interval AB, we have three cases. If f is continuous and strictly increasing on the interval AB, then f of AB is equal to interval f of A, f of B. If f is continuous and strictly decreasing on the interval AB, then the image of interval AB is the interval f of B, f of A. If f is continuous and not monotonic on the interval AB, then f of the image, then the image of the interval AB is the interval small m, capital M, where small m equal minimum value of f on the interval AB and capital M equals the maximum value of f on the interval AB. Exercise 6. Consider the function f defined on R by f of x equal x power 2 minus 4x plus 3. Determine the image of the intervals minus 3, 1, 3, 5, minus 2, 4, 2 closed plus infinity, and f of R. f of x equal x power 2 minus 4x plus 3. Since f is a polynomial, then it's defined and continuous over R. Its domain is minus infinity plus infinity. The derivative of f is f prime is equal to 2x minus 4. We have to draw the table of variation of f. To draw the table of variation of f, we have to study the sign of f prime. To study the sign of f prime, we first find the root of f prime. We solve f prime equal to 0, then x equal 2. Then we put on the table of variation the domain of definition of f, which is minus infinity plus infinity, then the root of f prime, which is 2. Since f prime is a first degree polynomial, then before 2 opposite sign of a, which is positive, a is 2, it's positive, then before 2 the sign of f prime is negative, and after 2 the sign is positive, is the same sign of a. Then f is decrease from minus infinity to 2 and increase from 2 to plus infinity. And f of 2 is minus 1. The limit of f at minus infinity is plus infinity, since the limit of f is the limit of the highest degree of f, which is minus infinity power 2 is plus infinity, and the limit of f at plus infinity is plus infinity power 2, since then it's plus infinity. F is continuous and strictly decreases over the interval minus 3, 1. Minus 3, 1. F is strictly decrease. Then the image of minus 3, 1 is f of 1, f of minus 3. F of 1 is 1 power 2 minus 4 plus 3 is 0. And f of minus 3 is minus 3 power 2 minus 3 into minus 3 plus 3 is 24. F is continuous and increasing over the interval 3, 5. F is continuous and increasing. Then f of the interval 3, 5 is f of 3, f of 5, and it's 0, 8. F is continuous and not monotonic on the interval minus 2, 4. Not monotonic, it's decrease and increase. So f of minus 2, 4 equals small m, capital M, which is small m the minimum value and capital M the maximum value. F of minus 2 is 15, f of 2 is minus 1, f of 4 is 3. The minimum value of f from minus 2 to 4 is minus 1 and the maximum value is 15. Then the image of the interval minus 2, 4 is minus 1, 15. If f is continuous and increasing over interval 2 plus infinity, then the image of the interval 2 plus infinity is f of 2 and limit of f at plus infinity. F of 2 is minus 1 and limit of f at plus infinity is plus infinity. Derivative of some functions. if f of x equal k, where k is a constant, then f prime of x equal to 0. If f of x equal ax plus b, then f prime of x equal a. If f of x equal ax power n, then f prime equal n ax power n minus 1. The derivative of radical x is 1 over 2 radical x. The derivative of 1 over x is minus 1 over x power 2. The derivative of cosine x is minus sine x. The derivative of sine x is cosine x. And the derivative of tangent x is 1 plus tan power 2x or 1 over cosine power 2x. The derivative of cotangent x is minus into 1 plus cotangent square x or minus 1 over sine power 2x. On derivative. 1. The derivative of u plus or minus v is u prime plus or minus v prime, where u and v are two functions in terms of x. The derivative of the form u over v is f prime equal u prime v minus v prime u over v power 2 with the condition v should be not equal to 0. The derivative of 1 over u is minus u prime over u squared with u not equal to 0. The derivative of the function a u power m, where u is a function in terms of x, is a m u power m minus 1 multiplied by u prime, and u not equal to 0 if m is negative. The derivative of radical u is u prime over 2 radical u with u greater than 0. The derivative of u dot v is u prime v plus v prime u, where u and v are two functions in terms of x. Sense of variations of a function. F. If f prime is greater than 0, then f is strictly increasing. If f prime is negative, then f is strictly decreasing. And if f prime equal to 0, then f is constant at a point A. Exercise 7 draws a table of variations of the following functions. 1. F of x equal x power 2 minus 4x plus 1. Since f is a polynomial, then its domain of definition is minus infinity plus infinity. First, we find the limits of f. Limit of f at plus infinity is the limit of the leading part of f, which is x power 2, it's plus infinity. And minus infinity power 2 is plus infinity. So its limit as x tends to plus or minus infinity is plus infinity. F prime of x is 2x minus 4. To draw the table of variation of f, first we study the sign of f prime. To study the sign of f prime, we solve f prime of x equal to 0. We get x equal to, then in the table of variation we put the domain of definition of f, which is minus infinity plus infinity, and the root of f prime, which is 2. The sign of f prime is opposite sign of a and same sign of a. A is 2, it's positive, then the opposite sign of a is minus and the same sign of a is plus. When f prime is minus, then f is decreasing. When f prime is positive, so f prime increasing, limit at minus infinity is plus infinity, and limit at plus infinity is plus infinity. And we substitute 2 in f, we get minus 3, which is the minimum value of f. 2. F of x equal x power 2 minus 9 over x power 2 plus 1. First, we start with limit of f at plus or minus infinity. We take the leading part of the numerator and the leading part in the denominator. Then we get the limit at plus or minus infinity of x power 2 over x power 2, which is equal to 1. We calculate f prime of x. F is in the form u over v. The derivative of u over v is u prime v minus v prime u over v squared. The derivative of u is 2x squared. The derivative of v is 2x over v power 2. We get 20x over x squared plus 1 all power 2. We solve f prime if x equal to 0. 20x equal to 0, then x equal to 0. In the table of variation, we put the domain. Domain x power, since x power 2 plus 1 is always positive, then the domain of f is minus infinity plus infinity, and the root of f prime is 0. A is 20. Since x power 2 plus 1 power 2 is always positive, we take the sign of 20x. Opposite sign of a is minus, same sign of a is plus. When f prime is negative, f is decreased. When f prime is positive, f is increased. Limit at minus infinity of f is 1. Limit at plus infinity of f is 1. F of 0 is minus 9.